Since we've already got port match CNC runners, we're just going to make sure we don't have any sharp edges and blend everything together. That's it for the port work on the heads. Next is another little blueprinting step. Touching up the oil return holes can help get the oil down to the pan quicker. And after this, we'll get these babies cleaned up and show you some precision valve train tech.
We start by putting a little modeling clay into the piston valve pockets. Add a little motor oil to keep the valve from sticking to the clay. Add the gasket, and with 2 checker springs in the #1 cylinder, we snug down the head. Then add 2 of the hydraulic lifters, push rods, and rocker arms. Adjust the rockers to 0 lash. Rotate the engine 4 complete rotations, and remove the head. Looks like we only have a tiny indentation from the intake valve, which means we have plenty of clearance from the valves down to the piston. Now remember, the minimum clearance should be 100 thousandths. That's why it's always important to check this.
Our new stainless steel valves are bigger, lighter, and stronger than the original factory ones. Now they're also undercut right here to help that airflow out into the combustion chamber a lot better. Now to make sure our valves are perfectly mated with our seats, we're going to lap them in. First, we'll put a little machinist die on the seat for a visual reference. Then apply Loctite lapping compound to the face of the valve and install it. Then use a lapping stick to spin the valve, lifting and rotating it until the valve seat is completely lapped in. And once you've done enough of these, you can actually hear when it's seated. This is important because the exhaust valves can see temperatures up to 1500 degrees. Now this little 40,000 seat area is the only way the valve has to dissipate heat, as it momentarily contacts the seat. Now since we've already got our cylinder heads apart, it's good engine building practice to go ahead and verify your spring pressure, and ours are set up for a hydraulic roller. Each one has an inner and an outer spring, and a dampener that will help stabilize it up to 7,000 RPM. First, we need to know the installed height. The checker will show us the exact distance between the spring pad on the head and the bottom of the retainer. Ours is 1'8". Next, we'll check each spring for its installed seat pressure, and we're looking for no more than 125 pounds. More than that could lead to a bent pushrod or a collapsed lifter. Now we need to verify our open pressure. Now what that is when the valve is open from the camshaft, the amount of pressure the spring's making to close it shut. Now what we're looking for is about 350 pounds. The reason we need that much is because at higher RPMs, it'll close that valve and keep it closed, keeping us from floating the valves. Our roller cam has 550 thousandths inch of lift. Now we just subtract that from our install height at the 1'8", and that leaves us 1'250".